All right, we're going to look at problem 14-20. All right, what we're going to do first is I'm going to draw my picture because I like to look at the picture. So the picture here is we have a block and it's 10 kilograms and it's hanging from a rope, which means there's tension because in any rope the force you have is tension. And then there's two other ropes and this is 30 kilograms. Okay, so that's the what's happening picture. Whenever you do any problem, step number one is you are going to draw a free body diagram for each mass individually. Okay, so first, here is my 10 kilogram mass, and the force of weight acts down, and we're not going to worry right now about where we're putting these. And I'm just going to call this FG10. That's just the weight of the 10 kilogram mass. I have this tension going up, which is already labeled T1. And then I have here T2, and I have T3. Then over here, I have my 30 kilogram mass. And I have the weight of this one, which I'm going to call FG30. So I'm just using that notation. Normally you would call them like M1, M2, F1, whatever. So then this is T2 and this is T3. Before we do anything, before we start summing forces, I have to establish my sign convention. So I'm going to say that up and to the right is positive. Now, when I'm gonna show you something, because sometimes when you do a problem, you don't know where to start. So I'm gonna show where I'm gonna start something where I probably shouldn't start there, but I'm just gonna show you because there's a reason why we're gonna do it like that. So I'm gonna start with this block just because I drew that one first. Okay. So when I look at this block, the first thing I'm always gonna do on every problem is I'm gonna write my sign convention. So in this problem, I'm gonna call up positive. Then I'm going to say I'm summing forces in the y direction, and this is equal to MA. Now, on that AP test, this is worth a point on the FRQ. So if you don't write that, you don't get that point. So you want to maximize your point. Now, because this is not moving, we know that this is equal to 0. That's another point. Now, when I took engineering classes, they always told us to go like this, up and to the right is 0. Because the acceleration is 0, the whole term goes to 0. But on the AP test, they want you to physically write is equal to 0 like that. Now, under here, this is where I'm going to now look at my free body diagram. I'm going to look at all the forces acting on the object. And now what I'm going to do is I'm going to add them up. So anything that's going up is going to be positive, and anything going down is negative. Okay, so I'm going to have T1 minus T2 minus T3 minus FG10 is equal to 0. On the AP test, this is now another point. So now I have 3 points. Now when I find my answer, that's only worth 1 point. I mean, I have to put the values in. So we have to pay attention to the point distributions. You don't skip steps because on the rubrics, they're going to give you points for writing certain things. So it doesn't matter if you get the final answer. You can miss out on most of the points in a question by not showing all these intermediate steps. Now, if I rearrange this, because I want to solve, let's say I say T1 is equal to T2 plus T3 plus FG10. I don't know T2, I don't know T3, and I don't know T1. The only thing I can find out is I can find FG10 because I know that FG10 is equal to mg, which is equal to 10 times 9.8, which is 98 newtons. But there's too many unknowns. So that's why I want to show you this first, that even if I do this first and I'm not finding an answer with that, that's okay. I can come back to that later. Does that make sense? So now we'll look at this other one. So now I'm going to look at this second one, and I'm going to write my sign convention up as positive. does it matter with this? Well, once we get into things moving and accelerating, you always want your sign convention to go in the direction in which the object is moving. And we'll talk about that on the next one. So summation of f of y is equal to ma. Again, this is going to be a point, so you have to write that. Now this is also not, so this is 0. Okay, so now what are we going to do? We're going to add up all the forces that are going in this. So if I look at my picture, T2 is positive, plus T3 is positive, minus FG30, and that's equal to 0. Now, when I look at this picture, and these are equal rows, these are distributing the weight equally. So T2 is equal to T3. So that's the hardest part of this, even though I don't know what it is. So because they're equal, I'm just going to call it T23. So I'll say 2 T23 is equal to FG30. So this is mg. So 2T3 is equal to the mass, which is 30, times gravity, which is 9.8. So 2T3 is equal to 294. So T23, which is T2R23, is equal to 147 newtons. Or you could just call it T. I just didn't want to get it confused with T1. Now I can go back to here. So now I know T1 and T2 are equal. So I can say T1 is equal to 147 plus 147 plus 98 newtons. So T1 is equal to 392. Oops, I forgot my 2 newtons. So what are the steps I did? First, I look at my picture. For however many objects I have, I'm going to draw a free body diagram for each. Drawing the arrows in the direction in which they act, that's the most important part. Now, there's no components here, so what we're going to do is for each free body diagram, we're going to sum forces, and because it's not moving, it's in static equilibrium, we're going to say it's equal to 0. So even though I started here and I had too many unknowns, I said, okay, let me go here. Sometimes we're going to have 4 free body diagrams. So you start with the one where you can find a value. Okay? And that takes practice.